Okay, this video is looking at how you go from atoms to ions. Now, people get a little bit confused with this because there's three things you need to know: it's atoms, ions, and isotopes. So you looked at isotopes the other lesson. If you had carbon 12, it's got 6 protons and 12, no, not 12, 6 neutrons. So that means it's got 6 protons. And this number tells you the protons and neutrons. Sorry if that was a bit confusing the way I said that. So this little number tells you how many protons. This larger number tells you how many protons and neutrons. This is called the atomic number. And this is called the atomic mass. We looked the other lesson at isotopes. Just quickly go over that again with you. If you had carbon 14, it still has 6 protons because you would change the atom that it is. It had a different number of protons. If it's 7, it'd be nitrogen. Okay. So again, this number tells us how many protons we've got. So what we can do here now is we always say, I sort of stole this from Mr. Pittaway, is we pen the atom. So we say protons 6. So that's the easiest one because it just tells you there. That number always tells you. I always say it's the smallest number, not the bottom number, because they can switch it around. So the smallest number tells us how many protons there are. This number tells us how many protons and neutrons. So you need to take away this number from that number to find out the number of neutrons. So this one's got 8 neutrons, because 8 plus 6 equals 14. The reason that it's protons and neutrons because they've both got an atomic mass of 1. Therefore, overall, this is the mass of that atom. Okay, the atomic mass. Okay, so slightly more difficult, electrons. So I'll use a different example for this. So isotopes, it's just when the neutrons change. So in this one, the pen would be, protons would be 6. Won't bother about the electrons for now, and then the neutrons would be 6 because 6 and 6 is 12. Okay, so in isotopes, neutrons change, protons do not. Okay, simplest explanation of the isotopes. Okay, let's look at sodium. Actually, lithium's the most simple one. So that's got 3 and 7. So if we pen the atom, protons 3 because it's a little number. Neutrons would be 4 because it's 7 minus 3 gives you the neutrons. Now I will tell you that there are 3 electrons. Now this is all about the charges because protons have plus, electrons have minus, and neutrons don't have one. So don't have charge, but they do have mass, which is really important. Right, for ions, so we'll put like a line through that, a curved line. That was isotopes. Now we're looking at ions. Now if I had Li plus, pause the video to have a go at this if you want, but how many positives would I need? How many more positives do I need than negatives for it to be plus 1? Okay, so that would be if it had 3 protons, 2 electrons, and then the neutrons stay the same because we're only bothered about the electrons changing in ions. So this didn't have a charge. Now, those of you who like maths will realise that plus 3 minus 3 equals 0. So there is no charge there. So you have 3 positives, 3 minuses. In this one, you have plus 3 minus 2, which equals plus 1. So we've got a positive charge here. Okay. I want you to concentrate mainly on penning atoms and ions this lesson, but I'm just going to go over quickly why that it always becomes Li plus, and that's because Li, when we had a look at the electronic configuration before, looks like this. Now atoms due to electrostatic attraction, once it becomes favourable in their energy levels to have a full outer shell. Okay, so that's what this one looks like. That's what that looks like. That's what its electrons look like. It's got 2 in the first shell, then it goes 8, 8, 8. Okay, that you can have 2 and then 8. So it's got 2 in its first shell and 1 in the next one. So this one gets lost, and then it becomes this. So that's lost. So it was this to start with, and it's gone from the atom to the ion. So it's going to be Li plus because it's got only 2 electrons. So the pen for it, it had 3 protons, 2 electrons, you can see there, and neutron stays the same. So you've got plus 3, minus 2 is plus 1. So lithium always becomes plus because it wants to lose that electron. It's because it wants to get down to this energetically favourable outer shell, full outer shell. Another example, if you had sodium, 2, 8, and then if it had another 1 there, it would lose that 1 to become Na plus. Okay, because it's losing a negative. People find that really difficult to understand. It's losing a negative, therefore it becomes positive. Usually when we lose things, it becomes negative. Like if I took away, if I went down degrees Celsius, it was in the minus, or I said, all right, I'm going to take some money away from you, you've got minus, and you're in the debt. Okay, so usually when we take things away, it becomes minus, but we're taking away a negative, which you know in maths, you minus a minus, it's plus. Okay, so surely that, hopefully that should have cleared some of that up. Have another go at the worksheets, and then email if you've got any questions. Thank you. Have a good half term.